So let's say we're asked to express the given radical as a monomial with integer exponents. We're basically asking you to convert the radical to a rational exponent. So what I'm going to do here is I'm going to simplify as much as I can inside the bracket. Remember that this is a quintic root, so we're only interested in that which could give us a repeat in groups of 5. So the 64 breaks down into 8 and 8, which breaks down into 2 and 4 for each set, which furthermore breaks down into 2 and 2. And then that leaves us with 1, 2, 3, 4, 5. So we can actually pull all of these outside the root. And this at least simplifies it before we convert it to an exponent. Okay, so then this leaves us with the following. So pull the 2 out, and then we did -3 times 2, that gives us -6. So now that I have this here, we're going to simplify it as much as we can. Remember that we're going to go from a radical to an exponential, and this works as... So the base to the rational exponent m over n is going to be equal to the root index n, and then x to the m inside the root. So what we're going to do is, one at a time, we're going to convert this way, so each of these to a rational exponent. So the -6 is going to remain there. They're going to -6, and then it's going to be x 4 over 5, and then y 3 over 5, and then z 4 over 5. And now we've converted this to a full exponential. So really, you just had to simplify it and then take one variable at a time and convert each according to the following formula. So express as a power with a negative exponent. So we want to express our final answer as a negative exponent. The expression 1 over the quartic root of 10 to the 2 is equivalent to. So remember that if I have x to the -n, that is going to be equal to 1 over x to the n. So what I'm going to do is, first, let's convert this to a rational exponent. So I'm going to take my radical and convert it to a rational exponent. That's the first thing. And then the second thing is I'm going to apply this law over here in order to turn it back into a negative exponent. So that being said, using this property over here, we're going to convert where the 4 is going to be the n and the 2 is the m. And so we're going to go 1 over, okay, that's going to be 10 to the 2 over 4, which if we write it even more simplistically, it's 1 over 10 to the 1/2, because you can simplify 2 over 4. Perfect. Now that we have our exponent in this form here, where this entire thing represents the n, now we'll just go backwards and write it like such. So for step 2, we're going to write the 10 as the base, and then it's going to be to the -1 over 2. And this is now a negative power, or a power with a negative exponent. And this is as simple as we can make it. So let's say we're asked to simplify the following radical expression. So what I'm going to do is I'm going to simplify these first. And remember that you can only add like radicands. Remember that the radicand refers to the number inside or under the root, I should say. So these are the radicands. Okay, so that being said, I'm going to see if I can simplify this here. That can break down into 3 into 9, and then that can be 3 in 3. And since, remember that there's the invisible 2 over here, we're looking for groups of 2 since it's a square. So we can pull out 1, 3, and that's going to give us this 5 times 3, and then what remains is this 3 over here. So 5 times 3, and then root 3 plus 4 root 3. Then that'll give us 15 root 3 plus 4 root 3. Since these are now like terms, we can add them. The radicands are going to remain the same, but the coefficients in front of the radicands, namely the 4 and the 15, are what are going to be added together. So when I go 15 plus 4, that's going to give me 19, and we're going to condense it as one radical. And the final simplified version is 19 root 3. So let's say we're asked to simplify this radical expression. Now, whenever we have a radical expression in the denominator, we need to multiply this by the conjugate. And remember that the conjugate is going to have the opposite sign to this one, okay, to the radical expression, which in this case is 1 plus root 5. Now, another thing is we have to keep the mathematical ratio the same. So the first thing we're going to do is we're going to multiply both the denominator and the numerator by the conjugate. And what we're also going to do is we're going to place brackets around the denominator, and I'm going to take it to the side and work out a little bit of distributive property in order to simplify the radical at the bottom. So I've done distributive property for the denominator, and I end up getting this expression, which, remember, is going to cancel out the root 5s. So I will also do distributive property for the numerator, and that's going to give me the following, where 2 times 1 gives me 2, and then it'll be minus 2 times negative 1 root 5, which could be negative 2 root 5. So that's at the top, and if we have a radical number at the numerator, that's fine. It's the denominator that we can't have that. And then since the root 5s cancel out, we're left with 1 minus 5, which gives us minus 4. And we could leave it like this, or if it can be simplified, we should. And so once we've simplified, we divided each by 2, then that left us with this final response here. So let's say we're asked to write the exponent in its simplest form. So I have x, which is outside the bracket, multiplied by 2 to the 1/2. So here's my exponent, close bracket, to the 6. So everything inside the bracket is raised to the 6. Well, what I'm going to do here is I'm going to multiply the two exponents. And so that's going to give me x to the 2 to the 3. X multiplied by 2 to the 3. Because 6 multiplied by 1/2 is 3. And then finally, this can be rewritten as follows. You can rewrite it as x multiplied by the 2 to the 3, which really just simplifies to 8x, as my 2 to the 3 becomes 8. And this is the simplest version of this original exponent.